So let's do this guy. First, make sure you guys understand the question. It says sand is falling from a rectangular box container. That's kind of annoying. Let's just say rectangular box. Let's get rid of that container word. It sounds like it's repeating itself. All right. Whose base measures 40 by 20 inches. Wait. At a constant rate. Wait. Sand is falling. Oh, it's falling at a constant rate of 30 cubic inches per minute. Okay, so I want to draw an image to kind of help us all understand this because that's how I think. And it might not be how you guys think. So here's my box. Okay, sorry, my box is a little bad. It has sand in it. Okay, I don't want to draw too much sand dots, but anyways. And there's sand falling from it, and it's forming this cone-like thing underneath it. Sand falling from it. Okay, wait. What is the rate at which the sand is falling from it? Okay, now this is kind of weird. 300 cubic inches per minute. Do you guys know what that kind of units are for? Volume. That's for a volume. And so that means the volume of the sand inside is changing at this rate. And the volume of this cone is changing at this rate. We understand that, right? If we were talking about the sand inside the box, is this rate positive or negative? Negative. And if we're talking about the sand inside this cone, is it positive or negative? Positive. Okay, so that's valuable to know that this is dV dt. I don't know. That might come in handy at some point during this problem. It says that this box is 40 by 20. Is that right? Yeah. Okay, and so there's all my measurements. This 40 right here, is it changing? No, it's not changing. The length of the sand right here is always 40 at this moment, and same with the 20. Okay. Now there's another dimension to this rectangular box, and that is the height. Is the height changing? Yes, the height is changing. The height is changing at a positive or negative rate. Okay, so I was just talking about this problem to try to help us understand it a little bit more. Now let's see what it says. How is the depth of the sand changing in the box? How is the depth of the sand in the box changing? Okay, so it wants to know dH dt. Okay, as soon as I read the question for related rate problems, because there's always so much information, I don't want to lose it. So I'm going to write really quickly what the heck I'm looking for. I want this. That's the question right there. I want dH dt. All right, so how are we going to get a dH dt in an equation type of a form? Well, I'm going to assume that we're going to use the volume one because that would have, what is it, base times width times height. Is everybody cool with that? And now you guys might be tripping in just a little bit because you're like, wow, look at all these variables. That's like the product rule twice. Calm down. We don't care about this guy and this guy. Why? They don't change. They're constant. So let's take them out. Let's put 40 right here and 20 right here, and we multiply those dudes together. We get 800. So the volume is this, right? The volume is 800 times H. That will give you the volume of the sand in the box, right? Right. Now I don't know what H is right now, but that's not my goal. My goal is to find the dH dt. So let's get dH dt. Let's take the derivative of everything with respect to time. So we get dV dt. On the other side, we just have this like scalar in front. We don't care about him. What's the derivative of H? So we have 800 dH dt. Oh man, this is what I'm looking for. I wish I knew what this is. Oh snap, I do. What is that? Oh, it is 300. Now I'm going to write it out, but this is wrong. Yes, it is negative. Right? Because the volume is changing at a negative rate inside the box. And so I put negative 300 right there. Now to get dH dt alone, I divide both sides by 800. It simplifies to a nice, pretty negative 3 over 8 equals dH dt. Oh, snap. You know what I didn't include? I didn't include the units. The question doesn't ask for units, but this is a very valuable thing for us to know. So what are our units for the height? Inches per minute or second? Minute? Minute. Oh, that's more pretty. So there's with correct units. All right, so this says the sand is forming a conical pile. There's a conical pile. That was my attempt to help you guys think about this. Look, there's the volume of the conical pile. At a particular moment, the pile is 23 inches high. Hey, there's an H. We have an H. We got to write it down. H is 23, and it's inches. Okay, it's that high, and the diameter of the base is 16. Oh, we know what D is. D is 16 inches. All right. The diameter of the base at this moment is increasing at 1.5. Okay, so dd over dt equals 1.5 inches per minute. Okay, at this moment. All right, now let's read our question. How fast is the area of the circular base of the cone increasing? Oh, but what? Area? Wait, we weren't talking about area at all. We were talking about volume. So it's trying to like play games with us. Let's see. What is the area of a circle? Pi r squared. Hey, that's a simple formula. That's probably why it doesn't give it to you, because you probably should know that. So this is the area of a circle. Then you might be thinking, well, it wants the how fast the area is going. So we're actually looking for dA dt. Question mark. So I'm thinking, well, give me dA dt. And so I take the derivative of this with respect to time, and I get dA over dt. Pi is not a variable, so I don't have to worry about him. He's a like a scalar, just a number, a constant. So I drop the 2, I get 2 pi, and then I have r, and then times dr dt. So it looks like in order for me to know what dA dt is, I must know what r is, and I must know what dr dt is. Oh, snap. But I have d and dd dt. Now, because... now this is extra stuff. I'm going to write extra stuff, so I'll use a different color. Because the radius is related to diameter, like so. And if we show that if we take the derivative with respect to time, we get 2 dr dt equals dd dt. So because of this, because dr dt is related to dd dt by 1/2 dd dt, which is a ddt. Okay. The rate of the radius and the rate of the diameter, they're what they call directly proportional to each other. There's a constant of proportionality that can relate these two. Oh man, all these big words. So what does that all mean? That means okay, if the diameter is 16, what's our radius? 8. If the rate of the diameter is 1.5, what's the rate of the radius? 0.75. Very nice. Is it still inches per minute? Yes. Nope, it's not a area. Okay, so now we plug our fancy numbers in. We get 2 pi times 8 times 0.75. Now, I don't like fractions. Let's go 3 over 4, because that's the same as 0.75. The 8 will cancel out with the 4, and the 8 becomes a 2. 2 times 2 is 4 times 3 is 12, so we have 12 pi. And what are my units for that? Inches squared per minute. Oh, man, we are amazing. We are fabulous. Good job. Thanks, Penny. Okay, now we've been working to understand this problem as we go, okay? And one of my hints to you, one of my tips is make sure you write down what the heck you're looking for before you start trying to look for stuff. Okay? So, look at this. It says, how fast is the height of the pile increasing? Now, acknowledging that you know that you're looking for this is very important. Okay? Oh, dH dt. Now, do we have an equation that relates h to all the other rates that we know? The volume one, right? The volume of our conical pile. What is that? What is that equation? It is V equals 1/3. Can you guys double check it for me? I think it's R squared. R squared times H? Okay, so R squared times H. All right, so cool. Now, I don't see any rates in there, so we know. You know, right? We got to take the derivative with respect to T. Did I do something? Pi over 3. Oh, there's a pi in there. Good looking. All right, so let's do this. The derivative of v would be dv over dt. On the other side, unfortunately, we have two variables that are changing. They're not constant, right? R is changing and height is changing, so we can't just plug a number in there and not worry about that rate. We have to keep them in there because they are changing. That's true with related rates. If your variables are changing in your scenario, then you have to leave them as variables. So we got two variables multiplying to each other. That means we have two functions of t multiplying to each other. And if we have two functions multiplying to each other, how do we take the derivative of them? The product rule.
Oh, you do that product rule.
Oh, very nice, German engineer. All right, so I'm going to ignore the power 3 because he's a constant scalar. We don't worry about him. Now, what is the derivative of r squared? It is 2r dr dt. And then I'm multiplying that by h plus, because this is the product rule, we have r squared. He's chilling now. What is the derivative of h? dh dt. Oh, that's the dude we're looking for. We want him. Okay, so do we know what this guy is, this guy, this guy, this guy, and this guy? Because we have to know all those variables if we want to find dh dt. All right, so what is dv dt? Was it negative or is it positive? Is the volume of the cone increasing or decreasing?
Increasing.
Increasing, so it's 300. Then we have our pi over 3. And then what was my radius? 8. And what was my dr dt? 3 over 4. What was my height? Suck. We have to find that.
Suck.
Okay, so let's keep going. We have 8 squared. And then we have dh dt, which is what we're looking for, right? dh dt. So we have to find the freaking height. All right, so you guys just want to tell. Oh wait, they give it to us, huh? Yeah. And here I'm like thinking I have to find it. I was gonna go back to this guy and see if I had to find it, but apparently I don't because we were given it. So it's 23. Back in the problem. Good thing I wrote that down earlier, huh?
Yeah.
Okay. We have a lot of work to do. All right, so I'm going to simplify stuff because that usually makes it easier, and I make less mistakes when I do it like this. So 8 becomes 2, and that 4 goes away. Right? Yeah, okay, that's good. All right, so 2 times 2 times 3. 2 times 2 is 4, and that's 12. 12 times 23. Ugh. What's 12 times 23? 23, 12.
276.
Thank you. 270 what? 276. And then we have plus. We have 64 right here. dh dt. Oh, not ddt. Stupid. dh dt. Okay. Do you guys want to get rid of that fraction? Make them go to the other side right now? I do. That means we would multiply this by 3 over pi. So that'll be 900 over pi.
Yes.
Oh, pretty. Now we don't need those brackets over there anymore. So we have 900 over pi minus 276 equals, divided by 64, right? dh dt. Now, this is pretty ugly. So, woo. I'm going to put parentheses on that. I'm going to say that, like if this was a college board exam, you guys would be able to leave your answer like this because there's no more calculus to do. But we're going to plug this into a calculator and find our final answer. So, this is our exact answer. If you guys plug this into the calculator, you'll approximately get 0.16, and I'm going to round that 3 up to a 4. And since this is height, it is inches per minute. Now, I think we're going to be allowing a calculator on this test, and so I'm going to want this answer because I want you guys to practice using it.